statistician's wife had twins. He was delighted. He rang the minister, who was also delighted. Bring them to the church on Sunday and we'll baptize them, said the minister. No, replied the statistician. Baptize just one. We'll keep the other as a control. And we're learning about control groups and experiments, and we're talking about designs of studies today. So, one of the things we need to know about, one of the first steps in a study, is to know who the study is about. So determine what population you want to study, and then determine if you can do a census or just need to do a sampling. A lot of times, if you can get everyone and do a census, that's great. But there are times you don't want to do a census, like, say, for a blood test. We don't want all your blood. All right, step 2, what do we want to know? So you need to formulate questions that will help you gather the data. Remember that the questions won't always be just like what your result for the study is. So for example, the percentage of people who have internet access, you would be asking instead, do you have internet access? Not what percentage of you have internet access. Now, questions or interviews that influence the outcomes can lead to bias. So I made this little cartoon here. Before I grade your test, please complete this survey on my teacher performance. And they all check thumbs up. Why is that? Well, they don't want the teacher to be upset while he's grading their tests. Questions should be objective. You can also do leading questions that can give you response bias. And remember that interviewers should always be courteous, ethical, and protect the anonymity or privacy. That helps minimize bias as well. So who do we gather data from? So if a census is too difficult or expensive, you might want to be doing a sampling instead. Most times you're going to need to sample and you'll have to figure out how. Now, the sample frame is the pool of possible participants. If there are individuals in the population who are not in the sample frame, this can lead to bias. For example, if I was looking at different respiratory systems and I went and sampled some animals that I found while I was walking around, this could be my sample frame here. And then I pull my sample and I go, oh, most of these guys have lungs and things like that. But who am I leaving out? Well, if I'm just walking around on the ground, I'm leaving out the animals that live in the water. And they have gill systems. I'm sure they have lungs as well, but it's a different respiratory system than what we're used to. So this is called undercoverage, when you leave a certain part of the population out and when your sample frame is not representative of the population. So how do we sample or assign? Be sure to use randomization in your study. If you let people volunteer, you're going to get the most extreme views. Odds are they will not be representative. And that's called voluntary response bias. I have this image here, and say I went to the cafeteria and I said, hey, I'm doing a survey on baseball. And who's most likely to come up and do my survey on baseball? Probably baseball players or baseball fans. So you can see here's the rest of the people in the cafeteria, and most people going up to do the survey are baseball players. And guess what? They love baseball. You might not get the same response as if you pick the volunteers instead of letting them pick you. Also consider timing for surveys to avoid bias due to non-response. So non-response would be when they say, I don't feel like you ask them to do the survey, right? But they say, nope, don't have time. Or they're not even there. So it would not be a good idea. I know most high schools have a senior skip day unofficially. So it's usually the day before spring break and all the seniors are like, oh, we're going to skip. So if you were doing a survey on the prom, that would be a very bad day to do the survey because a lot of your seniors would not be there. Now, also avoid methods that can be easily ignored. So if you're doing surveys through the mail, those tend to have a very high non-response rate. Now, looking at experiments, let's go ahead and look at the design of experiments. So we have subjects, which we will randomly assign to different groups. So group 1 would get treatment 1, and group 2 would get treatment 2. So first of all, you're going to impose a treatment. They don't get to pick the treatments. You randomize it. And then you have a control group. Remember the minister and the baptism? So you want to be able to compare, because if you have all of them take the treatment, how did you not know that they wouldn't all be better anyways? So you're going to have some of them have treatment 1 and some have treatment 2. Keep other variables the same for all groups the best you can, and then you compare your response variable. Now, sometimes you might be doing treatments that will be vary based on the type of subject. For example, if we're doing medications, males and females have very different responses to medications. As an example, women experience heart attacks differently than men do. Men tend to have the and then grab their arm. Women actually tend to experience indigestion. So my point is, medically speaking, males and females have different responses. So sometimes you really want to separate them into different blocks. So you could have one block for the males, and you're going to do the same thing we did with the other experiment, assign them to different groups randomly and compare the results. Then you would have a block of females, assign them to different groups and compare the results. Now, one last thing in experiments is called blinding. So blinding prevents bias by hiding the treatment type from the observer or the subjects. And they actually did a study on this. They said, oh, we're going to tell you that these students, we tested them and they were extra intelligent. And believe it or not, those students scored better. They made it up. They didn't score extra intelligent, but just the teachers having that opinion that they were influenced how they interacted with them. So you often want to blind one side. In this case, really, we want the teachers to be blind to your ability so that we treat you all equally. All right. And then if you blind both sides, it's a double blind. So another example where you have, so the teachers being observers, that would be this blind. A lot of times when we're doing medications, we don't tell the subjects if they're getting the actual treatment or the placebo. A double blind is when neither the people measuring it or the people taking it know which one. If you've ever seen House, there's an episode where one girl's going through a cancer experimental trial and she doesn't know which treatment she's supposed to get. And the doctors don't know which treatment she's getting, but the nurses notice the actual treatment smells funny. So the nurses weren't blind, and that led the doctor to say, oh no, she's not getting the treatment, and he did some naughty stuff. So blinding is very important to maintain impartiality.